Hello, welcome to the QCAA Methods External Exam Multiple Choice Solutions video. Don't forget today you'll need your formula book. So let's jump right into it. Okay, paper 1. Question 1. E to the ln x is equivalent to, so if you didn't know this already, E and ln are inverse functions of each other. So E and ln will cancel each other out and you'll just be left with x. So the answer to question 1 is C. Right, question 2. If the function is equal to e to the power of 6 minus 2x, determine the value of f dash 2. So the first step for this question is to find the derivative because it's got f dash. So the derivative of e to the x is equal to e to the x. But we have a coefficient in front of x. So when you've got a coefficient in derivatives, you bring the coefficient out the front. So f dash of x is equal to, bring the coefficient out the front, and you leave everything else the same. Now it's asking us to sub in 2, that's what f dash 2 means. So if you sub in 2 instead of x, you get, so this is equal to negative 2 e, 6 minus 4 is 2. So the answer to question 2 is D. If you got any of the others, you may have forgotten to bring the coefficient out the front. Alright, question 3. A bag containing buttons. So if 3 buttons are randomly drawn from the bag, which probability can be calculated using the binomial distribution? So binomial distribution is repeated independent trials. So without replacement is not repeated. So it has to be either A or C. And because A has 3 green, it's a repeated trial. So we're picking a green, and then a green, and then a green. So that's binomial distribution. So the answer is 3A. 3C, it's green and then a green and then a red, but the red is not repeated. So that's why C isn't binomial. And B and D are both without replacement, so the probability is going to change. They are not independent, they depend on each other. So that's not binomial distribution. All right, let's try question 4. If the gradient of a function is this, then f of x is equal to, so we've been given the gradient and we want to find fx. So that means we're integrating. It might help to bring the x cubed up the top. So indices laws, 1 over x cubed is the same as x to the negative 3. So whenever we integrate, we add 1 to the power. So negative 3 plus 1 is negative 2. And we divide by the new power. So we end up with negative 10. Bring this back under the fraction. So the answer for 4 is C. All right, question 5, another integral question. This one we're doing definite integrals. Let's test our definite integral knowledge. So first, integrate 1 over 2x. So we can bring the half out the front. You can bring coefficients out the front. So the integral of 1 over x is ln x. And so we're going from 1 to 3. We've still got that coefficient out the front. So now we're substituting in 3 and 1. So the answer is ln 3 minus ln 1. Hopefully you know ln 1 equals 0. So the answer is a half ln 3. All right, question 6. Substitutions for h are used to estimate the limit as h approaches 0. Which sequence is the most appropriate? So we could start with h equals 1. So a to the power of 1 minus 1 over 1. So it's a minus 1. Then we could try h equals 0.1. So a to the power of 0.1 minus 1 over 0.1. So this is the same as, so dividing by 0.1 is the same as multiplying by 10. Because 0.1 is 1 over 10. Keep change flip, so the fraction on the bottom flips to 10 up the top. So it's gone from a minus 1 to 10 times a to the power of 0.1 minus 1. Let's try h equals 0.01. As h heads towards 0, a is heading towards 1. So if we look at the 4 different answers, a is getting smaller, b is getting larger, c has crossed to negatives, and d is just going up in intervals of 1. So it can't cross over to the negatives because a is limiting to 1 regardless of what h values we sub in, regardless of what a value you use. So it can't be c, it can't be d for the same reason. It can't just go up at intervals of 1. And so as a to the power of h heads towards 1, it's going to decrease. So the answer is 6a. Alright, question 7. Determine the mean of a continuous random variable x with the probability density function f of x equals 1 over 8, etc. Okay, maybe the formula sheet could help here. So continuous random variable, mean, and it's given us a formula here. So it looks like this is the formula we need to use. So we're going from the boundary 0 to 4, and we're doing x times by 1 over 8 x dx. And so probably the first thing is to bring the constant out the front. So we're integrating x squared. 1 over 8, add 1 to the power, divide by the new power between 0 and 4. Substitute in the values. You end up with 1/8 times 64 over 3. And that equals 8 over 3. So that is the mean. And that is 7D as the answer. Alright, question 8. Here we go. A sample size of n was used to estimate, given the sample proportion was 0.6, determine n. Okay, so hopefully you might have heard about margin of error before. Basically, this is our confidence interval. So if we go to confidence intervals, this bit that we minus and add to p hat, this is our margin of error. So this is what we need to use. So let's substitute the values in. So the margin of error is 0.03. Our z-score is 1.96. And then we've got our p hat. If you didn't know, sample proportion is p hat. And that's divided by n. We don't know what n is. So we rearrange this. So divide by 1.96 and then square that. So this is equal to the top row divided by n. And so if we bring n up the top and divide by that, and we need to multiply these two together. These two multiply to 0.24. So the answer must be 8b. Alright, question 9, here we go. Seems like just a regular integral question. So let's have a go. So first of all, bring the constant out the front, which is pi. Integral of sine is negative cos. Check your formula sheet if you don't believe me. And we've also got a coefficient. So because we're integrating, we're going to have to divide by the coefficient. So then simplify this out a little bit. So this becomes 3 over pi. And so we can bring this out the front as well. That's a coefficient. So that will simplify to, if we multiply these, the pi's cancel. So you end up with minus cos 0. Hopefully you know your unit circles. So cos pi is -1 and cos 0 is 1. -3 times -2, which is 6. So the answer is 9B. All right, the last one, question 10. The continuous random variable y has a probability density function. Given all that, piecewise, determine the probability. Okay, so if you didn't know this, probability is equal to the integral of f of y. So we have to integrate between 0 and a half. And so the integral of that is y plus y. All right, so if we substitute in the numbers, a half squared over 2 minus 0. So this is a half. This is probably the trickiest part. A quarter divided by 2. Now, a quarter divided by 2 is an eighth. And so this is 4/8. So the answer is 5/8. 10C is the answer. All right, I hope you enjoyed paper 1.
All right, let's start paper 2. Question 1. If f of x equals sine 3x, determine the value of f dash. Okay, so obviously you need your calculator. I'm using the TI today. The good thing about the TI is you can input derivatives straight in, definite derivatives. All right, so first you go menu, 4, because we're doing calculus, 1, because we're doing derivative at a point, variable is x, the value of x is pi divided by 8, as you can see here. It's the first derivative, you press OK, and then we need to type in the function sine 3x. You press enter. This is in pi, which indicates it's in radians. You can see my calculator is in degrees, so I'm changing it to radians, and then I'm going to press enter, enter, so I get 1.148, which is question 1B is the correct answer. All right, question 2. The probability of hitting a bullseye on a standard dartboard is 1 in 1,250. What is the probability of hitting a bullseye exactly once in 10 attempts? It looks like we're going to need our formula sheet to check this. Here is the formula right here, binomial probability. So R is what you're trying to find. So it's hitting the bullseye once. So R is 1. N is the number of trials. So there's 10 attempts. So N is 10. P is the probability of it happening once. So 1 in 1,250. So we've got basically, it can't be B or D because they've got 9 as the power, but R is actually 1. So the only difference between A and C is this start bit here. And so it has to be C because there's 10 trials. So the answer is 2C. All right, question 3. We've got a normal distribution curve and it's 95% of the area lies between these values. So the first thing to do is get the z-score. So you potentially have memorized the z-score. If you haven't, you could memorize this instead. Statistics, distributions, inverse normal, and the area is 0.975. So there's a 2.5 on either end of the normal distribution, 0.975. So that's including the bit that's cut off at the start, the 2.5%. And so hopefully you've memorized this. This is your Z-score. Now, why do we need the Z-score? Any probability, you should be going to your formula sheet. Now, it's asking us to get the standard deviation, but we don't have n. It doesn't give us n. It gives us the area lies between these two. And so if you go to the confidence interval for P, you can see this is very similar to this. We just need to divide this plus minus z square root, etc. If we divide this by z, we're going to get our standard deviation. So how do we find the plus or minus z for p hat? Well, that's what this information is here. Take our calculator, that's from the highest to the lowest. We divide this by 2, and that's going to be this section here. Now we divide that by z, and we have our standard deviation, 16.16. Okay, let's do another one. Question 4, displacement of a moving particle. So displacement, velocity, acceleration, there's probably some sort of hint that, oh, we've got to use integration or differentiation. So we're going from displacement to acceleration, so we are differentiating. So I think if we just use this derivative at a point again, and we've got, let's make it t. T is 4. It's the second derivative because we've got to go displacement to velocity, velocity to displacement, and then we need to type in our function. So you'll need e to the power of 0.5 t minus 1. And so that's our answer, 4D. All right, question 5, here we go. Log questions, everyone's favorite. Hopefully you know your log laws. So we're trying to get x by itself. So minus ln 3.7 from both sides. Hopefully you know your log laws. If you're minusing 2 logs, you divide the numbers inside the logs. Only if it's the same type of log. So basically x equals 9.25 divided by 3.7 because they're both ln. So the answer to 5 is C, 2.5. Okay, question 6. It's asking us to find the integral, but we don't know what a is. So I think if we just guess an a value, so let's make a equals 2, and then do shift plus and type in the integral and press enter, we get the answer. 6D is the answer. Okay, question 7. Distribution of certain sample proportion has a mean of 0.7, standard deviation of 0.02. Determine the sample size. So if we go to our formula sheet, we're looking for mean and standard deviation. Mean of P, standard deviation of this. So if we rearrange this formula, standard deviation equals this, we will get our solution. So standard deviation squared equals this. We bring the n up the top and divide by s squared. So n equals this. So we need to type this into our calculator. Divided by the standard deviation squared. So n is 525. So the answer to 7 is A. All right, question 8. The number of koalas in a conservation park is modeled by the following log function. So again, rate of change, derivative. So we're going back to menu, calculus 1. Let's make it t in years. And we're looking for koalas when t equals 3. The first derivative, so we're going to type in the function. So that is the rate of change. So 4.77, which if we round up is 5. So the answer to 8 is D, 5. All right, question 9. If the function equals that and the derivative equals that, determine the expression for A. So I think we just need to do the derivative. So we've got two functions multiplied together. Let's call it u, derivative of u is 3. So we bring the coefficient of the power out the front for e derivatives. And if we make this one, we know this is 2. There's no coefficient for x, so it's just 2x plus 1. And so we have two products multiplied by each other, so it's the product rule. So if we go to our formula sheet, the first function multiplied by the derivative of the second, plus the second multiplied by the derivative of the first. So then if we factorize this, so there's two things, factorize them both. They both have e to the 3x, and they both have x plus 1. And so the first one, if we divide by this, you've only got 2 left. The second expression, you've got 3x plus 1 if you divide by this. So that means this bit here is A, and so A equals 2 plus 3x plus 3. So the answer is A for question 9. Right, question 10. A student's trying to determine which subject they perform best in compared to other students. So we've been given scores, and they're saying assume the results are normally distributed. So we have to convert the X scores to Z scores, so then we can compare them more evenly, basically. So this equation here, Z equals X minus mu over the standard deviation, is going to be how we're going to compare the 4 results. So we just basically need to type this into the calculator. So the student's result is X, the mean is 62, and standard deviation is 22. So that's the Z score for A. And so basically we just repeat that again for B, C, and D. That's B's Z score, that's C's Z score, and that's D's Z score. So if you look at the 4 Z scores, you can see that B has the best Z score. So comparing the 4 Z scores, the B result is the best result. So the answer to question 10 is B. Thanks for watching paper 1 and 2. I hope that was helpful. Don't forget to check out my other videos on specialist maths or physics. And I just want to dedicate this video to my 2021 cohort. You were a great cohort, specialist and methods. Well done, and I look forward to hearing how you all go on the methods exam. All the best, students.